Hello everyone, I'm Vinayak Koppad. So in this video I'm going to explain you the projection of solids. Let's begin with the problem. A square prism 35 mm sides of base and 60 mm axis length rests on HP on one of its edges of the base. Draw the projection of the prism when the axis is inclined to HP at 45 degree and VP at 30 degree. So first open the solid edge ST7 software, select the isometric draft and set the sheet to A4 size. Switch off the show background, click on save default, then click on OK. So click on the fit command. Go for sketching. So take a line command, draw the XY line approximately in the middle of A4 sheet and change the thickness to 0.15. Next go for the text command. And here so you can change the style to Times New Roman and write down the X and Y and VP as well as HP. Since we are solving the problem in the first quadrant, so this is the first step, preliminary step. Now so straight away take a rectangle by center command. Here the solid is resting on one of its edges. So here it is given that it is a 35 mm so take a smart dimension and show the dimension. Now in order to get the midpoint, join the diagonals, and these diagonals are the construction lines. Hence, so you have to change the line thickness to 0.05. So after this, go for the text command and go on writing the annotations here. So here A, and within the bracket I am writing A1 because it is not visible when you are looking from the top. Similarly B, B1. Next it is C, C1. Next D, D1, and in the middle it is O, O1. O, O1, yes. So these are the annotations. So here A1, B1, C1 and D1 represents the bottom face of the prism, and A, B, C, D represents the top face, and O is a midpoint of a top face of the prism, O1 is a midpoint of a bottom face of the prism. So after this, so project onto the XY line now. So and you can remove the extra projections here. Now you know the axis length. So axis length it is given in the problem that it is 60 millimeter. 60. Then press the enter button. Then draw a axis line. And here, so change the line type to the third one. You need to select the third one and select all these projection lines. Change the thickness to 0.05. Now take a line command and this also should be 60. Then complete all the lines. Now take a smart dimension and you can show the axis length here, and now again take annotations and go on writing the annotations here. Yes. Now so here so B is visible when you're looking from the when you look the square prism from the front. So the B corner is visible. Behind that you are having a which is not visible here. Since it is a front view, it is B dash, and within the bracket it is A dash. So similarly, so this one it is O dash, and again it is not visible. So that's why I write within the bracket. Now it is C dash, and within the bracket T dash. Now similarly at the bottom at the bottom side. So b1 dash, and within the bracket it is a1 dash. And here take a text command. So this point is c1 dash, and within the bracket t1 dash, and at the middle it is o1 dash, and that is also not visible, that's why write within the bracket o1 dash. Click on the fit command. So this is the first position of the problem. So in the next position, so the prism is inclined at an angle of 45 degree to HP. So for that, leave a small space here. First you need to draw a line which is inclined at an angle of 45 degree. Now, so the first front view position, select all the lines, so this is disturbing here, that's why. Select all the lines of the front view, and this you have to block it. Click on the block, click on the right mark, click to define the origin, and once again click it here. Go for the move. So I want to move, and again I want to copy here, so just take one copy of that. Then immediately after this you can use the collinear, then go for the connect. So this end point should meet at this point. Once you have completed this, you delete this reference line what you have drawn. Now unblock this one and go for the extend to next command, and just extend it, and now you can show the angle once again here, so which is nothing but a 45 degree. Now we need to write down the annotation. So as I told in the previous videos, so instead of writing, I am making use of a move command here. Just I will move all the annotations here. Yes. After this, draw the downward projection from all the corners. Also from O1 as well as O. Again draw the horizontal projections. Now first you remote all the extra projections. Select all the projection lines at a time, just holding the control key, and at one time you can change the thickness to 0.05. Yes, now carefully you need to locate first the top face, let us say A, B, C, D. So now horizontal A is here and vertical A is here. So A, now again similarly B, and now C is here, now D is here, and again D to A. So this is the top face of the prism. Similarly, so again next we will connect the bottom face A1, B1, and this is C1. Only thing is you need to locate the horizontal and vertical lines. So now I have connected the bottom face, and after that you will connect the side faces. So because always the boundary should be the continuous line, and here so the edge C1 D1 is actually not visible, that's why, so we have to make this as a hidden line. So go here, select second one. So actually this is not clearly visible because behind that there is a one more line here. So that's why what I will do, so I'll just split this line. So I want to split this line at this point, and I'll change this line type to Yes, now I think it is clearly visible. Now take a text command and go on writing the text here. This is A, B, C and D, and here it is A1, and next it is B1 and C1 and D1. So when you look at from the top, the C1 and D1 is not visible to you, that's why, so we need to write that within the bracket. Yes, after this we need to connect the axis here. So our O is here and O1 is here, so that means, so again I need to use a split command here. Split, I want to split this line at this point, similarly I want to split this line at this point. Now only this portion I need to change the line type, that is the axis one, and make it somewhat darker. This is the second position of the problem. Next, in the third position, so the axis is inclined at an angle of 30 degree to VP. That's means whenever axis is inclined to both the planes, we have to solve that problem by locus method. So now take a line command and here draw a line at an angle of 30 degree. Yes, once it is going beyond the paper means, so you can follow like this method. Draw one horizontal line from that, or else you can take a line here. Yes, now you can view angle here. This should be 30 degree and bring the lines within the sheet. Yes. Now change the line thickness to 0.05 here, and again here I need a reference point here. Take a point, click anywhere on this line and make it somewhat darker. Yes, so here first we need to draw axis length, first position axis length, which is nothing but a 60 here. Go for arc by center point and the radius will be 60 here, and you need to cut this 30 degree line. And here, so again in the intersection of arc and a line, so you need to draw the locus line. In the same way, we need to measure the second axis length here, which is coming out as a 42.42 or 43. So go for again arc by center point. So now it is 42.43, then enter. So zoom the area and you need to cut this locus line. So now take a line command, connect from this point to this reference point. Now you can change the line thicknesses which are used as a construction lines. Now the next step, select all these lines along with the axis. Now this we have to block it and go for the move, take a one copy of that. Now first I'll approximately rotate this one. Now use the collinear this axis with this line. Now drag this one. Now go for the connect this endpoint and this. So that means the OO1. So OO1 should be 42.43. Now, so first you unblock this one and delete this line. Change this line type to the hidden one. Sorry. So this is the axis type. Now again, once again we need to write down all the annotations here, and here I have forgotten to write the this is O, and again this one will be the O1. Again O1 is not visible, so that's why we have to write within the bracket. Now select all the annotations here, and just take a one copy of all those annotations. You can keep it somewhere and you can drag it properly here. So now this will be A1, B1, and again D1, C1. Now again B, this is C, and this will be A, this will be D, and O and O1. So this is the third position here. So whenever you are having a locus method, we need to measure the angle beta. So go for extend to next, okay, and extend this line up to the XY line or also horizontal line. So here I can measure what is the angle beta, so which is coming out as a 45 degree. Now again from all these points draw the vertical projections. So here you need a lot of patience because we need to connect all the points properly here. Again O to O1 also we need to draw it. From the fifth comma. Now again from the second front view draw the horizontal projection from all the points. So here since O1 is touching here, so I'll just leave it here only. Yes, so these are the horizontal projections what we need, and again so select the unwanted lines and just trim it. Now yes, 1 second. Select all the projection lines, and here again it has missed. Select all the projection lines, and change the line thickness to 0.05. Click on the fit. Now carefully locate all the corners vertical and horizontal and go on joining here. So vertical A is here, horizontal is here, and again we have to look it for the B now. Yes, so I think B is missed here, so it has to start from exactly B1. So just a small mistake what I have done. So trim this, again change the thickness to 0.05. So that's why you have to be very careful while drawing the lines. So take a line. So now I'll start from here. First I will connect the bottom face A1. So now again B1. So the B1 will be here. Next again C1. Next again D1. D1 will be here, and again D1 to A1. So I have connected the bottom face here. Now similarly, so connect the top face first. So vertical A is here, horizontal A is here. Similarly the B point is here, next C is here. Now again D point, next again D to A. Now I have connected the top face. Now you connect the lateral edges. So from here to here, all the lateral edges we need to connect it here. That is A to A1, B to B1, C to C1, D to D1. So after this again O to O1 also we need to connect. So the O is started here and our O is here. So this is O and O1. So we have to locate for the O1 here. Yes, this is O1 now. So you can just remove this extra projections and click on the fit. Select this. This is the axis line type. Yes. So here, so the D corner. So when you are looking from the front, so that is actually not visible. So that is not visible. So that's why. So the D point will be here, and the edges which are in connection with the D corner are not visible to us when we are looking from the front. That's why you make all these three edges as a hidden edges. So make a hidden edges, then finally you write down the annotations. So this is A, now this is B, now C, and finally this corner will be D, and as usual here. So okay, I have forgotten, so we need to use a dash and dash for the front view, sorry. So take a here, so this is A dash, now this is B dash, now C dash, and finally this is within the bracket it is D dash, because it is not visible when you are looking from the front. And similarly this is O dash, so O dash is also not visible, that's why I write it within the bracket. And finally here A1 dash, now this is B1 dash, next again, so C1 dash is here, and finally this is D1 dash, and again so O1 dash. Yes, this is the complete solution for the given problem. Thank you.